So far, we have looked at integrating functions that then give us an original function if you are to consider integration being the opposite of differentiation. All of those integrals had a special name and they were called indefinite integrals. And what that means is that essentially we are integrating the function for all values of x. We're now going to move to something called a definite integral. And in a definite integral, instead of integrating between infinite values of x, we are now going to introduce two limits, a lower and upper limit. So in the case of this function here, just a random function f of x. And if we wanted to introduce a definite integral, we could say integrate between this value here, let's call it a, and this value here, let's call it b. Now the concept of exactly what is going on in this definite integral will be covered in the next video. But for now, we're just trying to get you used to the skill and what you actually physically do. Now, the condition for a definite integral is that this function that I've got in blue has to be continuous between a and b. To write a definite integral, we are going to continue with our same notation. So the integral of the function in terms of x. But with our a and b, we're going to add the lower one at the bottom of the sign and the bigger one at the top of the sign. So this says now to integrate the function of x between a and b, and we are going to rewrite this as the anti-differentiated function. So we've seen that before, between b and a. Now to actually do the skill, we are then going to substitute b and then subtract substituting a. Now you may have noticed that I don't have a constant of integration here, and the reason for that is if we were to have one, so just as a side, if we were instead to go the function of x plus c between b and a, then I'm going to get the function at b plus c, and then I'm going to subtract the function at a plus c, and you'll notice that the two plus c's will cancel, c minus c, and so it's not required. This is the only time in integration where you don't need a plus c. Now, two examples about how to use the definite integral. So say for this one here, now we're still going to integrate using our normal rules. The power on the bottom of this fraction is not 1, it's a half, and so we've got to bring it to the top. Integral between 10 and 5 of 3 x minus 1 to the power of negative half. Well, that's going to be equal to square brackets, so now integrated and I've got my two lower and upper limits. We're going to raise the power of the bracket by 1 and then divide by the new power. Well, dividing by the new power is like dividing by a half. Dividing by half is like timesing by 2. And then I'm going to divide by the derivative of inside the bracket. Well, the derivative of the bracket is just 1, so that's just dividing by 1. I'm not going to write that down. And that will be between 10 and 5. Simplifying before substituting is always a good idea. 3 times 2 is 6. And instead of having a power of half, I'm going to rewrite that as a square root. I think it's just easier to see what's going on. Between 10 and 5. Substituting out those limits, we get the first one, 6 times the square root of 10 minus 1, minus the second one, 6 times the square root of 5 minus 1. I always find it's a good idea to put these in brackets, even if it's just like in this case, just one thing, just in case of any negative signs. That gives me 6 times 10 minus 1 is 9, and the square root of 9 is 3, minus 6 times 5 minus 1 is 4, and the square root of 4 is 2, equals 18 minus 12, which is 6. Number 2, integrating this one. This one is a product, and so we've got to think, well, maybe it's in the form f dash x times the function of x. I look inside the brackets because the brackets are definitely the most important thing here. And I see the bracket itself is 2x squared minus 1. The derivative is 4x. And in terms of the variable x, that is outside. And so this is in the form f dash x times function of x. And so I'm going to look to just integrate this section here. Equals. I'm going to leave the outside alone, giving me 2x squared minus 1 to the power 3 divided by the new power and the derivative of the bracket. So the derivative of the bracket is 4x between 2 and negative 2. The x's will cancel, giving me 1/12 times 2x squared minus 1 to the power 3 between 2 and negative 2. I'm now going to substitute those limits in. You get 1/12 times 2 times 2 squared minus 1 all to the power 3 minus 1/12 times 2 times negative 2 squared minus 1 to the power 3. That gives us 1/12 times 2 squared is 4 times 2 is 8 minus 1 is 7. So that is 7 to the power 3 minus 1/12 times, well, negative 2 squared is 4 times 2 is 8 minus 1 is 7. And I'm not going to bother putting that in my calculator because those two are exactly the same terms, and so I know that that's going to become 0. It is possible to get a 0 definite integral. It's also possible to get a negative definite integral. And the concept behind that is going to be covered in the next video. Now it's possible to do both these questions in your graphics calculator. Now for your exam, you have to get to this line here. It's an integration exam. You have to show integration. But then you can put it into your calculator. Now the risk by putting this into your calculator is that if you get the integration step wrong, you're not going to know. So I would highly recommend doing it all first, get an actual number, and then using your calculator to check. In your Casio graphics calculator, to do a definite integral, you're going to go to the main calculator mode, and then you're going to click option, and then you're going to go to calc. Calc stands for calculus, and then there are a few options in there. One of them looks like an integral sign. I think it says something like that. You're going to click on that, and you'll then enter the original function exactly as it's drawn here. I use the x theta t button for x, and then you're going to type the function in and then click the right arrow, which will give you to the lower limit. You'll put that one in, and you click the right arrow again and put the upper limit in, then click equals. Use that as a check, not as a primary way of solving anything. Final question. This is sort of a merit type of question. We're told that the integral between 6x squared and x cubed minus 3 is equal to 5. Solve for k. Now in this question, because k is on top, we are going to assume that k is greater than 2. So we're going to integrate. Well, it's a fraction, so I'm thinking maybe it's a log. I look to the denominator. That differentiates to 3x squared, which is very close to 6x squared. So this will be a ln integration. To do that, I'm going to bring that 6x squared to the side just for now, times by ln of x cubed minus 4. Then I'm going to divide by the derivative of the bracket, 3x squared. That will be between k and 2. That will equal 5. Those x squareds cancel, and we get 6 over 3 is 2. Ln x cubed minus 4 between k and 2 equals 5. Now I'm going to introduce my limits. I have 2 ln k cubed minus 4 minus 2 ln 2 cubed minus 4 equals 5. That gives us 2 ln of k cubed minus 4 minus 2 ln of, now 2 cubed is 8 minus 4 is 4. Because that is a positive number, I can drop the absolute value signs. Makes it a bit easier for calculations. Now if k is greater than 2, then in my 2 ln k cubed minus 4, that means that k cubed minus 4 will always be bigger than 0 as well. So I can also drop the absolute value signs there. Equals 2 ln of 4 plus 5. Divide by 2. Two ln 4 plus 5 divided by 2, and then take the e of the right hand side to give you k cubed minus 4 equals e to the power of that whole thing. At this point here it's a little bit messy. I would suggest just using your calculator. That actually ends up being k cubed minus 4 is equal to e to the power of 3.886. Obviously I'm not going to be using the 3.886, I'm going to be using the whole number stored in my calculator just for accuracy purposes, which means k cubed equals e to the power of 3.886 plus 4. Take the cube root, or the powering a third, of the right hand side, k equals 3.75. In terms of what's going on here with this definite integral, do look at my next video. That will explain in more detail about what this is, and hopefully that will help you come to terms with this concept.